This is the Anthrobiology Podcast, hosted by me, Gabby LaPera. Every 2 weeks, I interview a biological anthropologist about what makes us, us. Hello, everyone. Welcome to another episode of the Anthrobiology Podcast. Joining me today, I have Dr. James Cole of the University of Brighton. Good morning / good afternoon. How are you?
Hi, Gabby. How are you? Fine, thanks.
I'm so good.
Thanks for having me.
I'm so happy to have you back. And I say back, listeners, because Dr. Cole actually talked to me about cannibalism already, but that was some of your older research, and I'm having you on to talk about what you're currently doing. So hold tight on the cannibalism stuff, but I'm so excited to talk to you about what you regularly do.
Me too.
So I think that the best way to put what you do, and you can 100% correct me if I'm wrong, is that you're using the archaeological record to understand kind of the evolution of cognition in humans and human ancestors.
Yeah, I think that's a really nice summary. So, when you think about, I guess, just sort of as a bit of an overview for everyone, I look at human evolution as a broad spectrum, and that kind of covers 7 million years, really. But what I'm really interested in is the archaeology of that record. So the archaeology is the material culture that is produced by humans and their ancestors. And that record is really kind of the oldest that we have is 3.3 million or so for stone tools. But undoubtedly there are, I would imagine, sort of organic tools and things that have been used in the record for a lot longer than 3.3 million years, in the same way that contemporary primates use tools, wooden spears and things like that, digging sticks. But just because of that deep time, we don't get the preservation of the organic material. So the kind of the oldest tangible record that we have that connects us to these human ancestors is the stone tool record. And I look at stone tools, and from that try and infer behavioral and cognitive abilities that kind of the makers may have had. And I think where that gets interesting is that for much of the human evolution journey, the makers of these stone tools are not like Homo sapiens. So they're not like us today. They are people who are built differently, who look different to us, have a different cultural process, have a different environment that they've lived in. And, will have different brain structures that, as you go back in time, tend to get smaller. So brains have grown as time has progressed through human evolution. Though interestingly now, kind of post-industrial revolution, things, our brains might be kind of shrinking as we evolve forward. But that's just probably because we offload a lot of our cognition into things like technology and stuff like that we've been using. But that's probably another discussion. But kind of, if we think about kind of humans and kind of going back in time, particularly deep time, so beyond Homo sapiens, into people like the Neanderthals, Homo erectus, Homo habilis, even potentially Australopithecines. These are people who looked very different to us, behaved in different ways, and just trying to understand how they kind of engage with each other and the world around them through this kind of limited artifact record that we have a glimpse at is kind of really interesting.
No, I think that's an interesting thing about the brain. This is something that I used to get asked a lot when I was teaching intro to biological anthropology. Does brain size have anything to do with intelligence?
Yeah, that's a great question. And I think in its very broadest sense, yes. In the same way that, a mouse or a small rodent has a small brain, and a larger mammal like us, elephants, blue whales have bigger brains. So there is a broad correlation between brain size and intelligence at a very kind of zoomed out level. But obviously within that, there are nuances.
Right. So would a blue whale be like 10 times smarter than me? Because their brains are a lot bigger.
Well, not when you scale it to body mass. Okay. So I think that's the key difference, is that somewhere along the kind of primate evolutionary trajectory, and specifically into the hominin line, which is kind of the line of human evolution after our split with the last common ancestor with chimpanzees somewhere around 7 million years ago, we have undergone a process of development and and change around our bodies, but also around our brains. And part of that change, we see a chain, sort of an adjustment to the ratio of brain size to body size. And there's been a playoff, it seems, within human species or lineages or ancestors. There's a lot of debate about what to call this now, given that we've mated with Neanderthals and things, and Denisovans, and probably other human lineages going back. But basically, there seems to be a trade-off between brain size and gut size. So human gut sizes and human ancestor gut sizes have shrunk. And with that kind of excess energy around gut processing, our brains have kind of expanded to fill the gap. But evolutionary speaking, to grow an organ is really complex and demanding from a selective kind of position. So if our brains have grown or increased in size, there must be a selective pressure working pretty constantly on that kind of human ancestral lineage that demands us to have a big brain, or the advantages of having a larger brain kind of confer an advantage over kind of the gut shrinking and that kind of thing. So there's lots of interesting ideas about why that might happen.
Why did guts shrink, freeing up this like energy to go potentially to the brain?
Yeah. Okay. So
it's a big question.
Yeah, it's a big question, and it comes back to, I think, some really poignant. And I have to try and remember who did it. It was Leslie Aiello, and I can't remember the other person. It's the expensive tissue hypothesis.
Mm-hmm.
Okay, let me start with that. So the question about why guts shrank is a much debated topic, and it kind of links into what's called the part of the expensive tissue hypothesis. But effectively, the argument is that the quality of diet improves. So it used to be thought initially that protein was the key. So access to kind of high quality protein through potentially scavenging kind of kills that big carnivores have made and accessing kind of the leftover meat, or even potentially exploiting kind of the midday time zone where lions and other big carnivores kind of rest in the shade. You can kind of approach the carcasses or whatever and kind of extract what's left over. So it's part of a behavioral and as well as physiological change as we move from pre-Australopithecines into kind of our own genus Homo, and continue to, then kind of that continues. But effectively, it's about quality of diet. So it used to be thought that was protein, and protein was enough of a diet improver in quality to kind of, you don't need such a big gut to process the protein, but it releases a lot more energy and nutrients, and therefore you can start to kind of change your physiology. So, gorillas, for example, have a massive gut because they eat really hard, digestible vegetative matter. More recently, people have done some work that shows it might not just be protein, but actually fat, the access to fat, that would be key to kind of improving the diet. Hand in hand with that, depending on where you fall within that spectrum of kind of physiological change and kind of within the body shape and size, as I say, that's a process that goes through the Australopiths kind of into our genus Homo. You can also kind of look at other strategies that might enhance the quality of diet. So that might involve cooking. So some of the earliest cooking is potentially, or controlled fire use is potentially 1.3 million years ago. But a lot of interesting research has been done on about how birds of prey will follow wildfires to then kind of swoop down behind on char-cooked remains of rodents. And even, I think there's even been examples like chimpanzees following wildfires and then kind of exploiting the cooked meat there. So cooked meat gives a higher quality diet experience because you don't have to process it so much in your gut to release the nutrients. And equally, if you're using stone tools to kind of cut up things, you're using less energy there. You're kind of processing it as you go. So basically, it's about an improvement. The idea is that it's around an improvement in diet and quality of diet. And I think within that, it's not just about protein and fat, but it's also about a more sophisticated exploitation of the vegetative environment, insects. There's a whole range of things that kind of feed into this argument. But that improvement in diet means that you're not needing such a big gut to extract all the energy that you need. And therefore, you're producing initially excess energy that's got to go somewhere. then you're kind of looking at your group, you're extracting all those social cues, those complex interactions, the energy's going to your brain, and then it just becomes kind of a feedback loop of increasing diet quality, more complex group interactions, the need for a better brain, and it kind of that's a kind of a simple, or hopefully a simple explanation about why that might occur.
Yeah. So basically, what it boils down to is that bigger brains based on body size mean that the creature is probably more intelligent. However, Bobby having a bigger head than Millie Sue doesn't mean that he's actually that much smarter than her. He just got a big head.
Yeah, exactly. Yeah. And it's interesting because I know listeners might kind of have seen graphs of brain sizes being plotted. And quite often, when you look at Neanderthal and Homo sapiens brain sizes, you see that they're quite interchangeable, but there's generally kind of an outlier that Neanderthals may have had a slightly larger brain. In reality, they probably had the same size brain as Homo sapiens. And we talk about that kind of general average spread across the population. But where the idea that they had a bigger brain comes from is really from a single sample. It's a single data point. So, there's variability in our populations today in terms of body size and even brain size and that kind of thing. But generally, as a whole, kind of got to look at it kind of like a species level of kind of behavior and cognition.
That's really interesting. I feel like that's something that you see in basically every intro textbook is that Neanderthals in general had much larger brain size. Brain volume is the metric that we're looking for. Sorry, I'm
Yes.
still waking up. um, so you're looking at tool use and cognition, but there's like another component to this just beyond just like the physical brain size that you're looking at. You're actually trying to understand like what's going on in their heads. And in order to do that, you utilize something called theory of mind.
Yeah. So I mean, this will get quite. I guess probably quite a technical answer maybe, and kind of go into some depth. But many years ago, gosh, almost 10 years ago, I guess I kind of did my PhD as part of a project that was called the Archaeology of the Social Brain. Lucy Talang was the archaeology of the social brain. Now, the social brain is an idea put forward by Robin Dunbar that he explained that brain size increased due to a selective input from group size. So the fact that we in today's world kind of we use people might use Facebook or social media, text messages through phones to connect with family and friends. And we are quite social animals, so we like to gather all of that gossip from all of our different networks and kind of absorb it and kind of assimilate it and think about where that leaves us in terms of our immediate network group, where it leaves us in kind of being able to talk to our friends about what's happened with the latest. I don't know. I'm not really into gossip personally, but I know other people are. So I don't know what people will gossip about. Maybe like what TV show they're watching, or whatever. And you've got profiles on Instagram and various other social media sites of one individual following to 50 million or whatever it is. But all of that are kind of connections with people, right? So that means that being descendant from that primate lineage, we are very social. And what Robin Dunbar's idea was is that there's got to be a reason why brain sizes increase through human evolution. And what he kind of tracked was that brain size increases and could be linked to group size.
Hmm.
And as guts shrink, releasing excess energy to somewhere in the body, and that we sort of mentioned before that seems to be channeled to the brain. Kind of what he kind of put forward is then, okay, if brain size is increasing, we can model that group size might also increase. And how he does it is he looks at primate group sizes, so chimpanzees, gorilla, orangutan, and things. And generally speaking, those groups tend to be capped at about 50 as a maximum. If you look at human groups, so these are hunter-gatherer groups or ethnographic groups, or even actually it sort of seems to be borne out by more recent research by Robin that it plays out on Facebook and other social media entities. But the maximum group size that kind of an individual surrounds itself with is about 150. So that 150 is not the limit of your followers or your influencers. That 150 are people that you generally know quite well. So it's not friends of friends, or it's not, on Facebook or Instagram, whatever. It's not, just your 10 million followers. You don't know those 10 million people, but you might know about 150 kind of generally as a maximum quite well. And that can be your close family, close friends, maybe extended friends, cousins, things like that. But it generally maxes out at about 150 as a kind of a close connected network. So you've got these two group size numbers at kind of two ends of the spectrum. And in the middle, you've got brain size kind of increasing. And what Robin Dunbar sort of suggests is that what you need to do within these groups is track social interactions. Now, in primates, you track social interactions and you groom up the hierarchy. Okay, so that, if you get into a fight, you're the people that, the other people that you've been grooming and things, and grooming within primates is very tactile. So I'm kind of waving my hands at the screen kind of to illustrate that. But, it's tactile grooming. They do it checking for fleas and bugs and nits, and, it's touching each other and making sure that they are spending enough time grooming the right people. And because it's tactile, it means that they can really only spend as a maximum about 20% of their day grooming, because they have to find food, rest, eat, move around the territory and that kind of thing. As humans, we don't group tactilely generally. Maybe with your kind of very close immediate network, but generally we don't. What we do is we groom vocally. So we use language, we talk to people. So within human evolution and behavior, there also has to be a transition from a system of grooming and social group construction cohesion, which moves away from the tactile into the vocal. So part of this is looking at the origin of language then too. And with language comes ideas around symbolism and so on. So to kind of go back to the story about great brain size and group size increase, number of 50 at the bottom of kind of a modern day primate analogy. And that is cats, because, you can only spend 20% of the day with that tactile grooming process, as well as kind of meeting all the other demands. And then at the other end of the spectrum, we've got about 150 Homo sapiens group size maximum in a broad figure. It's obviously more complicated than that, because, you have smaller units like, immediate family of 5 to 6, and, slightly bigger, kind of closer family and friends, maybe 25. Those are other numbers that kind of come into those human group constructions, but it kind of maxes out at around 150. So to get to that 150 and to drive kind of group cohesion and everything else, we also have to be able to then break that group cap barrier that the 20% of the tactile grooming places on us to get to the 150. And that the vehicle to do that is through the origins of language and the use of language, whether that's verbal, from, the way that we're speaking now, whether that is initially by looking at visual cues, so hand waving, utterances to punctuate things. But the reason why that starts to come back to your question about theory of mind, kind of finding to loop it back, is that you need what's called a theory of mind to have the basis of that language. And then this kind of links into another strand, which is called orders of intentionality. And this is kind of an ordinal scale of cognitive complexity based on how many mindsets you can hold internally. And what we can see is that primates, so chimpanzees, gorillas, orangutans, generally operate at a first order of intentionality. They blip into second order of intentionality occasionally, but they don't do it all the time. So some individuals operate there quite comfortably, some don't.
What is that, though? What does that mean?
Okay, so what that means is trying to think about how many mental states that you can have in your mind. So I know what I think.
Mm-hmm.
That's first order of intentionality. A second order intentionality would be two mental states. So I can believe or think that you, Gabby, are thinking, what is James talking about?
Okay.
So I can kind of infer a mental state for you, right?
Mm-hmm.
But the crucial thing when you start talking about theory of mind and these orders of intentionality is that they have to be different mental states to the one that you hold. So it's not just projecting your mental state onto somebody else. And that's a big difference, because primates are very good at projecting their mental states onto their contemporaries, generally speaking. So say some individuals and things operate at a higher level more frequently, but generally at kind of a broad species level, it's kind of they're limited to that 1 to that 2 boundary. And then you kind of get more complex, you start projecting 3 different mental states. And kind of, people have expressed this more eloquently than I, but if you think about kind of the best screenwriters, so take Shakespeare, for example, for a story of Shakespeare to work like Othello, there are potentially 5 mental states at any one time in that story for it to work, where Shakespeare has to understand that the audience is viewing the plot from Iago's perspective, who then believes that. I don't actually know Othello that well, so it's a terrible example for me to kind of bring to this discussion, but hopefully you can kind of see that you start to kind of play out this. But the important kind of thing around this is that because it's an ordinal scale, the levels of complexity ramp up exponentially at each mental state that you try to access. Now, in our daily lives, most of us operate at probably a second and a third order of intentionality pretty comfortably. We can potentially, as a species, kind of move up to 5 and 6 as a general kind of maximum, but not all of us do that, and we actually don't need to. So, you kind of engage in this kind of these scales of complexity when you start to kind of track different social complex relationships. So when we come back to kind of the evolution, the group thing, it's basically tracking relationships of your contemporaries with each other. So, who is friends with who, maybe wants to become better friends with somebody else. And then you have to kind of keep track of those relationships so that you don't inadvertently sidetrack, your friend who wants to become better friends with somebody else. So it's keeping up that kind of the complex kind of, another way to phrase it perhaps in our parlance is politics of group dynamics, right? Kind of always kind of understanding who is working with who is operating here, what's going on, and you can track all of that. And that kind of helps you in your then kind of daily decisions about how you interact with people and kind of the plays you might make in your social life, family life, and that kind of thing. We're constantly tracking what others are doing. And, our brain size, Robin Dunbar's idea is that brain size are increasing because as group size increases, and group size might increase because it provides better protection against predators, it might enable the group to be more successful to adapting to things like rapid climate change in the past. Pick any number of reasons why you might think the group size would increase. But it only works if you can maintain social cohesion. And you can only maintain social cohesion within larger groups if you're capable of tracking all of these different kind of interactions that people have with each other so that we don't upset the balance of the group.
Okay.
Does that make sense? Am I kind of making sense?
Yes. No, this all makes sense. My question is, how do you go from stone tools to theory of mind?
Okay. And that's where it gets, I think, that kind of that's where it gets really interesting and the kind of what I have tried to kind of do within some of the work that I've done. And again, there are some chains of inference here, but they get firmer as you kind of become more familiar with it. But the first kind of premise is to understand that the stone tool that you're looking at. So the thing that I really study a lot are Ashurlian hand axes. And for those who don't know what those are, there are different technologies of stone tool development through time. Starting, they have names like the Lamenquium for the oldest at 3.3 or so million years ago. Then perhaps the more familiar Oldowan from about 2.4 to about 1.7, which is when an object called the Ashurlian hand axe comes in. And then after the Ashurlian, we have things like kind of what's sometimes called mode 3 or prepare core technologies, Lavawa technologies, which as we kind of, that comes in about 300,000. That's where we start to get composite tools and things. So there's a long development and chain of stone tools.
And I'm just gonna chime in real quick and say it's worth looking these up online because I think you'll get a much better understanding of what we're talking about, just like having that visual image in front of you. The other thing is that you don't just have to look at pictures. There's a lot of people who like try to recreate the creation process of this. So if you go to YouTube and like type in any of these words and say like creation or like even just like flint knapping, like you'll get a better appreciation for how difficult and complex these processes are.
Yeah. So, I mean, what kind of the background to that? Thanks, Gary, because that's really helpful. Definitely go have a look. There are lots of experimental nappers who do really great and amazing stuff. But effectively within material culture development, we see a move from something that's quite functional to something that goes beyond function, that might have some kind of social cultural meaning attached to it. So, for example, if you're talking about this hand axe that I've been talking about, these Australian hand axes, these are the first objects where we start to see deliberate shape and form being imposed onto the artifact. So they are being shaped to look in a particular way. And if you're not Googling it, you can imagine it almost looks a bit like a pear. So a bit like a pear shape. Typically, you have a bit of a tip, gets wider in the middle, kind of gets rounded towards the base. They might also be what we call ovates, or more oval shape. It might also be what we call cleavers. So they've got like a flat tip, which might be like a think like a butcher's cleaver, almost like a blade, and then kind of trims down, kind of keeping a rectangular sign, then kind of narrowing at the base. So there's this variation in the shape and form of the Acheulean large cutting tool, sometimes also called. But the point is that from about 1.7 million years ago, this is an additional toolkit to the what we call flakes and cores, which are kind of what was prior to that. And the flakes and cores are kind of things that you can use to butcher carcasses, crack open long bones, flakes being bits that you detach from the core. So in order to napstone, if anyone's kind of tried to do that, you can't just whack a rock against a rock and think something's going to happen. You have to understand the angles of napping, typically 90 degrees or less if you want to extract something. So kind of within that, you've got this kind of technological development where these kind of ancient humans 3 million years ago, 2 million years ago, are understanding the fracture mechanics, not in the way that we would understand it today, but they understand, that you have got to hit it at a certain place to extract a flake of, not of a certain shape, but potentially of a size, or just extract anything. But then from about 1.7 million years ago, they're starting to add deliberate shape and form. So they're starting to refine the art and technique of tool creation, and they are starting to deliberately construct tools of specific forms to either perform specific functional jobs or to also play a role in some kind of social culture interaction. So they start to use material culture in their kind of construction of their social lives. Now, we do this all the time. And we do it so commonly that we probably don't even realize we're doing it. So listeners, you're doing it right now just by sitting down or walking or listening, but you did it this morning when you got dressed. You made a conscious decision about kind of what kind of clothes you were going to put on, what that style is. You make a conscious decision about if you wear jewelry, what jewelry that is you're wearing, or if you're not wearing jewelry, why you're not wearing jewelry. There's a decision there around the kind of bag that you carry, the brands that you buy. We use material culture to say something about ourselves to everybody else around us all the time. And we do it quite consciously, but we also do it quite subconsciously too, potentially, right?
Yeah. And I want to tease something out here too, which is that there's both like the sense of personhood that you're expressing with like your choices, but then there's also the function, right? So like, for example, if I go camping, I'm not going to take a purse. I'm going to take my hiking backpack, which is of a certain brand. So there's like kind of those two levels that are working together.
Yeah. And it's quite easy for us to engage with those two levels, because generally, our brains are big, and we can do all of these different orders of intentionality, and we can engage with the theory of mind, and we can use language and symbolism to construct all of these messages about ourselves and tailor our messages to the context that we are in. And we can shift those messages and context. So your example there, Gabby, between going hiking and going to work are two potentially very different messages and different sets of gear, but we can do that because we have a cultural selection process that kind of drives that.
Yeah.
But that's not always necessarily been the case in our evolutionary behavioral and cognitive development. So what I'm really interested in is, when in the past do we start to see human lineages or ancestors starting to try and proactively engage in the construction of material culture that also feeds into the construction of their their social life, their cultural perspectives. And why that's important is because, for these things to have meaning, you have to be able to tell and explain to somebody else in your group what that meaning is. Otherwise, they look at what you're doing and think, what are they doing? And they might misread and misinterpret it. So, for example, say, I don't know, I bought a Ferrari right now. For me, that's going to be an ostentatious, not an ostentatious, but a display of wealth. I've got the spare cash to have a really high-end sports car. But say, for example, Gabby, that you came from a background where actually wealth is not measured in sports cars. It's measured in, I don't know, anything else, gold bars, right? Okay. You could look at my sports car and say, well, that doesn't mean anything because you don't have, 60 gold bars stacked next to it. That's for me is my understanding of wealth. And I'll go, but okay, I might come from a culture that recognizes gold bars and sports cars as having kind of a display of wealth. But the point there is if you're not tapped into the cultural message or the kind of the language of what that message is doing, it could be lost on you completely. If I'm making sense in a very kind of bad analogies, right?
Yeah, no, totally. Because this is all relying on whether or not you have to understand whether or not the person in front of you is understanding the culture that comes around whatever action it is that you're doing.
And that's what culture is. Culture gives the scaffold of that commonality of understanding. And, that's why, in the world today, we sometimes struggle with differences in culture because we are misreading and misinterpreting what something means, because you're always going to reference it back to your reference point, which is your culture and social experience. And, we try to understand different cultural and social experiences and understand the context in which they're in. And we do that to greater and lesser degrees of success. But, to understand actually what people are intending, there's got to be a common framework of understanding there, if that makes sense. And, where we miss on those interpretations, or whether those frameworks of understanding are alien to each other. And then, I think as a species, we're generally quite good at learning these new things and understanding that. But, just look at the state of the world today. It's, we often choose not to perhaps be kind of engaged in that kind of the effort that needs to understand those other perspectives. But the point there is that, for this material culture to be used in that way, and then out of extension of that symbolism, and with symbolism, then you have to have kind of grammatical language. There's a whole developmental sequence there of why we behave the way that we do. And that is a sequence that has been going and building for many millions of years. It doesn't just kind of appear. Well, I don't think it appears kind of out of the blue. Other people might argue otherwise, but I think it's a very gradual process that we see kind of developing and building as we move through time.
So with the tools, you're saying like the form and the function suggest a degree of intentionality.
Yeah. So, for example, to go back to the Acheulean hand axe, and these are artifacts that have been produced by 3 or 4 different human lineages, so potentially Homo erectus, Heidelbergensis, Neanderthals, even Homo sapiens. And it's a longevity from about 1.7 million. Generally, people kind of put an end at about 200,000, but probably, even sub 100,000 in some areas of this particular form of hand axe. Because we produce hand axes again in the Neolithic and later prehistory of a different type and shape, but effectively they are hand axes, but they belong to a different technological and cultural kind of position. And I think within what we call the Acheulean, the fact that different human species are making these artifacts, for me, means that they're not all making them for the same reason, because different human species engage with material culture in different ways. And increasingly, I see the archaeological record and the deep time record really as kind of a very dispersed and scattered hunter-gatherer populations across vast, relatively empty landscapes of people. So you've got to, for me, I think what you have is a continuous process of innovation and re-innovation of these kind of technologies by a group. So what we see at this kind of very zoomed out position in 2022 is a conflation of many millions of years of artifacts being deposited in sediment. But we don't see the kind of months or the years or the decades or even maybe the thousands of years that form that accumulation, and therefore the different groups that kind of produce these artifacts. So what I'm saying there is that accessing that deep time is complex. And often we try and simplify that story to make it kind of easier to understand, I guess, or to make it kind of easier to engage with. Within my work, I've kind of been saying I think we need to embrace the full complexity, because it's only if we kind of really admit that actually it's complex, it's not straightforward, and there's not a continuous presence of tool makers for many millions of years, all doing the same thing over and over again. I think that's when we start to understand the surprising things that come out of sites and objects and dates and times, and increasingly understand what seems to be a very kind of group of human lineages that seem to have kind of interacted with each other a lot rather than kind of stayed very separate. So, kind of with the hand axes and things, you've got this imposition of form and shape, and particularly the argument is that they are symmetrical. And now my research shows they are symmetrical, but not the majority of the hand axes. Some hand axes within assemblages are symmetrical. Others kind of have a more varied form. But when you look at these symmetrical hand axes, because you are napping these two sides, and if you think about it in 3D, kind of the profile as well, to kind of fit a very predetermined shape and form. Listeners thinking in your mind like of a symmetrical pair. If you just kind of think about it in plan form, if you cut it in half, that sort of shape, it's the same on one side as the other. The idea that is that the imposition of symmetry is not something that confers a functional advantage. There have been studies that have looked at hand axes that have been napped by experimental nappers to be symmetrical versus ones that are sort of just a more general hand axe shape. They don't seem to confer an advantage in terms of function like butchery. So the hand axes are handheld tools which are used to butcher carcasses but work wood. They are handheld processing tools. So you're not throwing them at an animal to try and kill them, or you're not halving them on a spear or anything like that at the moment. These are processing tools to work the environment around you. So the symmetry doesn't seem to give a functional advantage in butchery or woodworking or things like that. Some might argue that it does give you a longer cutting edge around the entire circumference of the artifact, and that's true. It might well do, but you can also get a cutting edge around the circumference of a non-symmetrical artifact. It doesn't have to be symmetrical to get that cutting edge. So the imposition of symmetry has been used as an argument that this is something beyond function, that the maker 1 million years ago, or 500,000 years ago, or 1.5 million years ago, wherever you fall, but the maker has deliberately decided to make that artifact symmetrical. And there have been lots of interpretations to think why you would make an artifact symmetrical. So one idea is nicknamed the sexy hand axe theory. And I don't buy into it per se, but it's a really useful idea to demonstrate how a stone tool can be used, or how we can infer its use within kind of, group or social cultural interaction. So the sexy hand axe theory is that you make symmetrical hand axes to demonstrate your skill. And by demonstrating your skill, you are then able to attract a mate. Now, in the original idea, I think it's fair to say the assumption is that the nappers are male, and they're producing symmetrical hand axes to show females how skillful they are. Females would then gravitate towards those who can produce the most symmetrical hand axes because they're the most skillful, and kind of then choose to mate with them. And in a very kind of simplified, it's a bit more nuanced that, but in a very kind of simplified way. Now, in truth, we don't know. There's no reason why women weren't napping hand axes. Why females weren't napping hand axes. There's no reason why that would just be males. There's no reason why even potentially children wouldn't be learning how to nap hand axes. So, the picture now we know is much more complex, and we tend not to boil it down to those things. But I think what it illustrates is just a way that you can look at something that was made 1 million years ago and think, that's a symmetrical hand axe. Was someone doing that to demonstrate their skill, to try and, kind of woo the person that they are interested in to kind of, be with them? I think that's probably a useful analogy. But other ideas are that, they are to kind of help produce things around group identity or demonstrate that napping styles are socially learned. So individual groups develop a particular way to nap a hand axe, and that they pass on the knowledge of how to do that to the next generation, the generation after that. So that shows that learning is socially learned rather than kind of just an innate quality around napping.
Can you trace cultural contact through hand axe shape between different groups?
Um, not directly, but as archaeologists, we are in a part of the discipline's development is a focus on typology and looking for similar form and shape, and then kind of trying to, is that being tracked, and transmitted. But I think probably one of the best sites to illustrate what I was just talking about there is a site in the UK called Botsgrove. So this is a site that's dated to about 500,000 years ago, and it's a landscape that is exposed for probably about 70 years or maybe about 3 generations. And what you can see in this landscape is a kind of in situ, so primary context deposits of hand axes across this kind of intertidal landscape. And the hand axes are all remarkably similar in terms of their shape. So they're ovate and they've got a particular kind of what we call a tranche-shaped blow across the tip. And what that just basically means is that a final blow has been taken across the tip as kind of what we think is like a resharpening blow, or a blow to kind of create a fine sharp edge. But it's a remarkable consistency in shape and form from this site over this kind of 70-year period. And, the idea there, and Matt Pope has done a lot of work on this, and Mark Roberts and others. But, the idea there is that, that is a socially learnt way of napping a hand axe across that kind of 70-year period. And so to come back to your question, you might be able to, but it's very rare that we have the resolution of the stratigraphy and the archaeological sites to say definitively, yes, look, this form starts here and it moves to this site 20 kilometers away and then 60 kilometers away. It's very rare, if not impossible, to kind of track that kind of movement in the archaeological record. But, it doesn't stop us trying to infer that. And we see that it's not just with hand axes, but with any kind of stone tool shape, where you see similarity in form, there does kind of large, unless they've been independently innovated. So that comes back to my earlier point about, I think we've got lots of these small populations that do independently innovate these things over and over again. But there are also, examples where you might have social connections. So just recently, last week, they were talking about a house and sport type artifact, which is a later Stone Age. So Homo sapiens sub 60,000 years ago, Southern Africa, very similar forms across South Africa, which kind of suggests there might be a socially networked kind of community there. So you can track this and make these inferences when you look at stone tools, but always with an element of caution, I would say.
I have another question about material, which is I'm assuming that there are materials that are preferred for making these hand axes. What if you live somewhere without those materials? Are you still seeing hand axes?
Yeah, the answer is yes. So basically, if a hominin can nap a hand axe, they generally do. Now, when you're dealing with rock, the more fine-grained the raw material, the easier it is to nap. The more coarse-grained the material, the harder it is to nap. So, for example, in Europe, flint is the preferred raw material type by far. It's very fine-grained, siliceous raw material. Naps really easy, you get a really sharp edge. You see things being not hand axes, but in later periods, you see obsidian being worked to produce blades. Some surgeons today use obsidian because it leaves, I think it's the edge is sharper than steel, and it doesn't scar as much as steel does. So we still use stone tools today in a whole range of surprising contexts. But yeah, the finer grain the raw material, the easier it is to work. But what's interesting is that even when you have evidence of hominins in landscapes that don't have fine grain material, they are still napping stone. And they are able to impose shape and form on quite tough, coarse grain materials. So yeah, that also then kind of speaks to kind of a broader ability around cognition and behavior, and the ability to apply learned techniques to different raw materials as you move across these landscapes. So you're not just limited to learning a technique on one raw material, but you can apply it to other raw materials. So you see things like bone hand axes, for example, from some sites where they've taken kind of big megafauna bones and kind of worked that to create a shaped hand axe. So there's an ability to jump across raw materials to reproduce artifact form. For me, that really shows the adaptability of the hominin lineage. And, I think part of our success as Homo sapiens and other human kind of lineage species are our plastic behaviors, our abilities to learn and adapt to new environments, to apply the lived experience that we've had before and rework that in a way that allows us to kind of move forward as we kind of move through time, as we move through landscapes, as we move through changing social, cultural, and climatic and environmental conditions.
Yes. Sorry, the entire time that you were talking, I was also thinking about a very particular social interaction, which I don't know if this happens to men, but women, you go into a bathroom and there's always a drunk girl in there and she's like, "You look amazing." And just thinking about like the complexity of the like intentionality and like the mind, the theory of mind that has to go into that comment is wild. Now I'm just going to spend all day looking around, looking at other people being like, there's so much that goes into these interactions. Do men do that?
I know. Not generally in my experience, but maybe I've been going into the wrong bathrooms. I don't know. I don't know. But I think what you're saying, what you're pulling out there, Gabby, is that we are not a simple species. Every interaction that we engage in is loaded with social cultural cues. It's loaded with past lived experience cues. It's loaded with expectation. It's loaded with, a whole range of emotions, as well as kind of slightly, detached cognitive kind of functions around what we do. We are not simple. But what we like to do more than anything is simplify everything around us. We boil down all arguments. We take all the complexity out of it and we simplify it. It happens in political forums. So, Brexit in the UK was boiled down to something against immigrants versus keeping the status quo. And the argument was won because it kind of appealed to a more populist ideal, because it's a simple tagline that taps into what people want versus kind of understanding more complex functions. There was a cartoon I saw the other day. It was two booths. One says, the simple lie or the complex truth, and everyone's queuing in the cartoon outside the simple lie, and nobody's kind of wanting to hear what the complex truth is, because we like to simplify the world around us. We like to categorize things. We like to boil it down because it makes it easier for us to process stuff, I guess. What I've been trying to do through my career and things is actually say, no, it's not simple. It's much more complex and nuanced than that, because we are complex and nuanced. Everything that we do is complex and nuanced. So why are we simplifying the story of our evolution, of our development, whether that's behavioral, whether that's cognitive, whether that's cultural? Why are we simplifying this and boiling this down to saying, well, that group of people, that group of species could only do X, and this group can only do Y, but we can do X, Y, and Z? Because that's not what it's like. You can see that in terms of how our attitudes to people like the Neanderthals has changed over the last 20 years. People still use Neanderthal as a trope to represent kind of something that's less intelligent than us. And that's just not the case. These are hugely behaviorally complex human lineage who could speak with language, could produce jewelry, produce cave art even now, it would seem. They could decorate themselves. They could produce complex tool ranges, as complex as tool ranges that Homo sapiens produced. They are behaviorally complex. We mated with them. We have Neanderthal DNA. Populations of the world tend to have percentages of Neanderthal DNA in their makeup. For me, that engagement with Neanderthals and Denisovans too, because we also have Denisovan makeup in some populations of the world, that those interactions were not just because they happened to be wandering a landscape and came across something that biologically groups recognized as something else was compatible. I think for me, those interactions also occurred because they recognized something that was behaviorally and cognitively compatible. And, if I drill it down to my own experience, right? If you think about who you're attracted to, generally it's people that you kind of relate to. They have there's a similarity there, whether that's the type of music that you listen to, the type of shows that you might watch, the hobbies and pastimes that you might want to do. But there's a relatability there and a familiarity. Don't tend to be overly attracted to people who are utterly different to you in terms of personality, in terms of interest, and and that kind of thing. That's not always the case. There's always the exception to that rule, of course, but generally speaking, we kind of engage on similarity. And that's where I think, recognizing that our human ancestors in the past are more like us rather than more different to us is a real key shift in our understanding of that complex level of human evolution. But I should caveat that everything that I'm kind of saying, there are lots of people who probably don't agree with what I'm kind of that position. But I default to that more complex position because I've yet to be convinced that it is more simplified. It's also more simple and an explanation. I've always thought it's more complex than that, and kind of that's what I've tried to understand by looking at these physical remains of a tool that kind of was last handled 500,000 years ago, or 200,000 years ago, or 1,000,000 years ago. When you hold a hand axe that's 1,000,000 years old, the last person to make that was 1,000,000 years ago, and the world that they stood in was very different to the world that we stand in, and the kind of the group dynamics and the people that they're seeing and the animals and the environments are just so removed from us now that to try and access that kind of sort of mental state, alien, the fact that it's unknowable almost, is one of the great joys of doing that kind of research, because you're genuinely kind of looking into something unknowable and different to us, which I think is just mind-blowing.
Yes. I think one of the interesting things is if you look at your publications list, it looks like 3 different people are working on similar topics, because like you do seem to approach it from a lot of different ways, which, feeds into this idea that you really believe that it's a complex process, and to understand a complex process, you have to look at it from a lot of different angles. I have questions that relate to something from much earlier in the show, but the question is, you mentioned that our brains may have shrunk over time.
Yeah, so I it's not research that I'm hugely familiar with, but I think there's been sort of an interesting study that shows modern day populations versus, say, end of the Pleistocene into the Holocene, and kind of looking forward that our brain sizes might be, they haven't stayed the same size as they were at the end of the Pleistocene 10,000 years ago. And there's been sort of a suggestion, an idea that brain size is shrinking. As I say, I'm not hugely familiar with this research, but I would kind of bet that it's really kind of centered around the fact that we are off what we call, or what sort of those in the artificial intelligence community call, offloaded cognition. And we do this, in our lives, through rituals. When you get dressed in the morning, you get dressed, and normally if you're anything like me, you get dressed in the same order. So, X goes on first, Y goes on second. This is positioned here. That's a routine that you do every day. You don't have to think about that routine. The routine that you do to make your breakfast, the routine that you do to commute to work, or whatever it is, that's a routine. Routine is the way of offloading cognition. It's just something you kind of go into automatic pilot on. You don't have to think about it. You just kind of go through those processes. We also offload a lot of cognition through our technology use, and that's really ramped up, in the last 20 years. We've all got computers in our pockets that are more powerful than what they sent the original spaceship to the moon in. We offload our social interactions through apps. We offload a lot of our cognitive things through technology. And that's, this is just the last, where we are now is kind of, it's not the end of our technological story, but it's just the end point of where we are today. of something that has been going on for millions of years, where we've used technology and development and changes in tool shapes and forms to kind of aid our ability to engage with the environment. But my point here is, if you're offloading a lot of this stuff onto our technology, then you don't need to kind of have these potentially these big brains to constantly keep track of and hold that information there. So as I say, I'm not hugely familiar with that research, but I'm kind of making an educated guess that that's kind of where it's going.
That's interesting. I'm going to look into it because the other thing that's an interesting pairing is that we talked about brain sizes increasing with intelligence
Mm,
on a like larger like body ratio species size level,
yeah,
but we're also as a species doing incredibly like increasingly more complex
yeah.
things.
So this then comes down to the difference between natural selection and cultural selection. And kind of we as a human evolving lineage have probably been under a cultural selection model for probably the last 500 odd thousand years. So that's where, we're not operating under the rules of natural selection, survival of the fittest, and all of those things that people will be familiar with. But we're operating under cultural selection. So we're operating under the cultural rules of our societies around what is determined, to be the most attractive, or the most desirable kind of people to mate with, or and that cultural selection is could introduce a level of complexity that is utterly not accessible in natural selection, if that makes sense. And the fact that we've been operating under cultural selection, while Homo sapiens evolved, say broadly 300,000 years ago, we've certainly been under cultural selection there. But even pre-Homo sapiens, it just shows how embedded material culture and technology is within the way that we frame and construct our social networks. And we're almost at a really extreme end of that. It's really ramped up over the last 10,000 years, when we ceased to be hunter-gatherer groups, quite mobile across landscapes and more sedentary. And then, all the other developments that came with that. So, we are doing more complex things, but because we're under cultural selection, our bodies and our brains don't need to respond to each other in the same way that they would if you were under natural selection.
Right. And that's not to discount, like, we still have a lot of elements of natural selection in our mate
Mm-hmm.
selection choices. It's just there's also this cultural selection. It's the way I always told it to my undergraduates. I was like, imagine you go into a bar, like, you're still going to probably opt for one person over the other.
Mm-hmm.
And that's natural selection. There's a lot of cues that are bound up in there, but there's also an element of cultural selection.
Yeah. And also, of course, what we battle with in our society today is that, we are told what is beautiful and what isn't.
Mm-hmm. That's very true.
We get fed that through media outlets, through adverts, showing people what is supposed to be the epitome of what we should find attractive. And this, comes back to the symmetry debate. There's people with symmetrical faces, and there's been lots of studies around that. But, being told this is what you should find attractive is a cultural thing. We could reject that message. We could reject all the adverts that kind of show beautiful people, we in the West would consider beautiful people within that context, and just not buy any of that stuff, because it's, we don't want to kind of perpetuate that message and kind of go for something else, right? But we don't, because it's part of that cultural kind of messaging and construction that kind of drives overtly and subliminally kind of all of these interactions that we have.
I've never really realized it, but apparently I am very interested in this like overlap between biological and cultural like selection.
Yeah, because we don't understand it.
No.
We don't understand it at all. It's in many ways, I mean, archaeology as a discipline, really has been only formalized maybe over the last 150 years or so, as with all of these kind of science. But actually, people have been engaged in this for many thousands of years. But we still understand so little about ourselves, and so little about, the influences that act on us, and the interplays between biology and culture. It's still very new in some ways, even though we already, you might consider we have come a long way and we know a lot. But it's, certainly within my subject, I feel like whatever we know is just a drop in the ocean of what we don't know. And every new answer or every new kind of advance brings another set of questions, to try and understand that big picture. But that's what science, that's what education is, that's what science is, that's what learning is all about. It's about pushing that desire to know more and create these more complex kind of understandings and pictures of the world around us.
Well, on that note, I'm going to turn to the final three questions of the interview because you've been very patient and you've shared a lot of your time with me, and I really appreciate it. The first question is, what if people wanted to learn more about your work, where would be a good place for them to start?
Okay, yeah. Gosh, that's a good question. I guess probably one of the places to start, which we have not spoken about today, but we have before, is probably my cannibalism paper from 2017. Because in that, particularly in that paper, I try and take a topic, but also kind of embed it in that kind of broader understanding. Now, it's a bit out of date now because it was written 5 years ago, but I think the essence there is still present. So that's also, I think, quite an accessible read around an interesting topic that people may or may not kind of like. I also wrote a review paper more recently in 2019 with Julia Galway-Witham and Chris Stringer, where we kind of did a bit of a review around physical and behavioral sort of responses around hominids over the last million years or so. That's can't remember the exact title, but you can Google Julia Galway-Witham et al. 2019, Journal of Quaternary Science.
It's Aspects of Human Physical and Behavioral Evolution During the Last 1 Million Years. It is a very good article. I read it in preparation for this.
Yeah, so that's a good one because it gives a nice overview of stuff, and kind of I talk about the behavioral aspects in there a lot, and Julia and Chris kind of put in a lot around the bioanthropology and things, and it's a really nice overview of things. So those are probably the kind of the two good starting points. If people are interested in things like hand axes and symmetry, then I have many more papers on hand axes and symmetry than I cannot remember their titles of, but kind of probably one from Thomas Wynn's Stone Tools or Stone Minds. That's probably a good book to kind of look at because I talk about orders of intentionality, theory of mind, and kind of the development of that. Stone Tools and the Theory of Mind, I think it's called.
Yeah, there's also Napping in the Dark. Yeah, Stone Tools and a Theory of Mind.
Yeah.
That I think was also super helpful.
Yeah.
Second question, what are you reading for work right now?
Wow, that is a good question. And I can give you my honest answer, which is not a huge amount for work, other than kind of trying to do paper reviews when I get requests. So
sometimes people tell me I'm grading 100 undergraduates research papers. It's like you're still reading for work.
Yeah, so we're definitely in the marking season. So I'm not sort of proactively reading, but yeah, so that's quite embarrassing for an academic, I guess.
No, it's okay. Like I feel like when I was in academia, I went through waves of like I'm reading a ton, and then I'm literally just reading things that I have to read that are not actually helping me at all. Like especially during grading season, that's the big one.
I think I have the guilty secret that I have a long list of things to read. I have lots of browsers with papers and PDFs that I've downloaded into folders, and I hope to get to them this summer. But generally, when I do kind of read things, anything around Stone Tools, morphology, cognition, behavior, I also follow a couple of kind of key people in my field and kind of try and read the points that they have, like Chris Stringer or Eleanor Cherry, who is kind of a mix really of kind of leading lights in kind of the stuff that we do.
Yeah. My computer shut down unexpectedly the other day, and I was almost relieved that all the tabs were gone.
It does create a kind of a sense of pressure, doesn't it? When you sort of...
It really does. Third and final question is, what are you consuming for fun right now? It can be like a book, a TV show, podcast, whatever.
So I think generally if it's not my two small boys who are utterly exhaustible all the time, but a source of joy and frustration, as I'm sure every parent will relate to, we generally try and kind of just chill out in the evening. So I noticed that For All Mankind is back. We really enjoyed the first two seasons of that. Look forward to see what the third one will bring. But I also quite like Scandi Noir. So watching Borgin on Netflix. I think it's the 4th season there, which is always enjoyable to kind of escape a bit down that route.
Well, thank you so much for joining the show and sharing all your answers and your very complex and nuanced perspective. I really appreciate it.
No, not at all. Thank you so much for having the patience to listen to it.
Of course. You're welcome back anytime. Thanks for joining me for this episode of the Anthrobiology Podcast. If you have questions or comments, you can reach me at gabby.lapera@anthrobiology.com. That's spelled GABY.LAPERA@anthrobiology.com. This show is produced by me. Music courtesy of Chad Crouch, aka Poddington Bear at Sound of Picture.